Hi folks, this is take 2 on question 6 from the Unit 6 assignment. Okay, so here they're giving us this function and they're asking us to determine two rates of change. The first one is an average rate of change. Okay, so when they're asking for an average rate of change or a slope of a secant, they need to give you a starting point and an ending point. Okay, so essentially, if we think of, this function probably looks something like this. Okay, and here you got 0.1 as your starting value. So you're going from this point to say this is 10, and there's your ending point. And what you're asked to find is the slope of this line joining those 2 points. Okay? In other words, you're finding the slope of a secant line. Okay? That's what the average rate of change is represented by. So to find the slope of this line, well, just y2 minus y1 over x2 minus x1. So you're just finding f at 10 minus f at 0.1 over difference of the x values, 10 minus 0.1. Okay. Now they are asking for an approximation, so I could just stick this into my calculator, but these are actually pretty nice numbers because this is log of 10 squared minus log of 0.1 squared. This will just be 9.9. Of course, we know log of 10 squared, since these are inverses of each other, that's just equal to 2. Gives me the original input. And here, 0.1 can be written using base 10. So this can be written as 10 to the negative 1 squared, so that becomes 10 to the negative 2. Okay, and so this just becomes 2 minus negative 2 over 9.9. Okay, and here, since I am looking for an approximation, let me take my calculator and approximate that. So 2 minus negative 2 is 4 divided by 9.9. Okay, to 2 decimal places, so that's 0.40. Okay, now in the second one here, I'm looking for an instantaneous rate of change. Okay, meaning at this point in time, when x is equal to 10, what is the rate of change of this function? Now, what represents the rate of change of this function at a point is the slope of the tangent to that function at x equals 10. Okay? Now, this is not something that's easy to determine. Okay? We saw that by just drawing a line as an approximation for a tangent didn't work very well. So what we do is we use a point that's very close to x equals 10 to determine the slope of a secant. Okay, so I take a second point and I determine the the slope of the secant between these 2 points. Okay, so the slope of the tangent is being approximated by the slope of a secant. Okay, and what interval we use? Well, we can choose as small an interval as we like. Okay, but the idea is to get very close to x equals 10. So the interval that I suggest as a convention is to go at most 0.01 away from 10. So it could be 9.99 if you want to go to the left, or what I'll choose, 10.01. Okay, and if you want a better approximation, well, you take 10.001, and a better one, 10.0001. But this is good enough for our purposes. So to estimate the slope of the tangent, we use the slope of the secant joining these 2 points. Okay, so now I do exactly what I did before. I find the slope of the secant line, so f at 10.01 minus f at 10 over 10.01 minus 10. Okay, so here we have log of 10.01 squared minus log of 10 squared, which we already found was equal to 2. Over 0.01. Okay, and at this point here, I'm going to stick all of that into my calculator, let the calculator do the work for me. So here we have log of 10.01 squared, okay, minus 2, and divided by 0.01. Okay, so if we take to 2 decimal places, this is approximately equal to 0.09. Okay, so just to recap, average rate of change, you have to be given some interval or a starting value and ending value, and that just is represented by the slope of the secant joining those 2 points. To approximate the instantaneous rate of change, you're approximating the slope of the tangent, and you're using a secant of a very small interval, including the point in question. Okay, that's it for these.